So our project is the Locator AI, and our contents were, the first thing is our mission, the team, data collection, model training, analysis, front-end development, our numbers and conclusion.
So the aim of this product was to create an AI capable of estimating the country of origin from a single image through an automated analysis of the geographical and environmental features identified from the image. I'm Cash. I worked primarily on the front end.
I'm Evan Larson. I worked on the front end and data collection.
I'm Larry He. I worked on front end and also on data collection.
I'm Gurshan Brar, and I worked on training the model and also worked on the data set collection.
Hi, I'm Gurshan, and I worked on the back end and a little bit on the front end.
So here's our timeline. Okay, so first thing we did was the data set collection. And during the data set collection, we found several data sets of geotag images and Google Map images and web scrape images using SERP API of street views of various countries. We collected about 1,500 images for each country and put them into Overflow. And after that, we put them to Google Drive. And then the next thing we did was using vision transformers. We were able to transform our patches of images to manage the data set. And then lastly, training. Using the data set, we trained the model. While training, we did face various challenges, but then we ended up training in 4 different ways, which took a lot of time. But in the end, the model took just a couple hours to finish.
So to train our model, we use Google Colab so that it can give us more processing power. For our base model, we used also Google's just a vision transformer base. We had 6 classes for 6 countries, Brazil, Canada, Finland, Japan, the US, and the UK. And each class had around 1,500 images, which is around 9,000 for all the classes added up. And actually, before we were using a CPU on Google Colab, and it was going to take forever to train. So we decided to use the TPU, and we did this by importing the PyTorch XLA module, which allowed us to interface with the TPU. And then for our optimizer, we compared ADAM, which is Adaptive Movement Estimation, with SGD, which stands for Stochastic Gradient Descent. According to our research, SGD was supposed to be more optimal and take longer training time, but we actually found that ADAM was faster and gave us more accuracy. And then one more note right here, we had to comment out the gradient accumulation steps because the TPU did not support it.
For our front end, we based the theme heavily on the theme of the AI Camp website, and we made carousels and images for the model. Our site was made with HTML, CSS, Bootstrap, and JavaScript, and we used Flask for the backend. It was made from a template called Freelancer off of Bootstrap. So we faced several challenges when we were making the front end. The first was with the carousel. When you click on the image, it should upload it to the model. However, we had trouble with that, so we had to convert the images to base64, which took a while. And another problem was when we were trying to display the various graphs of data in the training process on the website, that did not work well since the graphs were just screenshots of the graphs. So we had to create a custom graph using an HTML canvas and program it completely using JavaScript, which gave us a lot of freedom and allowed us to make cool animations, which you may see during the demo.
This is our confusion matrix for our model. It shows how many times our model was right and when it was wrong. The x-axis shows where the model guesses, and the y-axis shows where the image actually was. The yellow and green diagonal line through the middle of the matrix are all the times the model guessed right. The other squares are the times it guessed wrong. Using this computer matrix, we can determine the accuracy of our model, which is 75%.
Okay, so here are the graphs that we got after training the model. In the graph that's in the top left corner, it shows that the accuracy reached about around like 0.8, which means 80%. And then the second graph shows that like how many steps it took during the training. And then the graph on the bottom left shows the loss over time, like during when it was training. At first it was at 1.4, and then as it gets less, it means that our model is like has way better accuracy. So it was going well until it's stabilized a bit. And then here's our runtime and then samples per second during the training.
As you can probably guess, there were lots of problems we encountered during our project. When we first started, we had planned on having 18,000 images. However, when uploading and training this data, we realized it would take more time than we had hoped. So we decided to shrink our dataset to only 9,000. Our dataset didn't have enough images for every country, so we had to use web scraping to fill the gaps in the data. This led to some outlier images which we had to manually sort through. Because some countries were so similar, the model had a hard time differentiating between them. We decided to take out France and put in the United States instead, as the US has more distinguishing features.
Okay, so this is the end. Now for the demonstration, I'm going to share our website. Okay, so this is our website. And as you can see, here's the model, which you guys can try out. And then if you put in, it's supposed to give the country and the confidence. And here is also the cursor, which you can click around to see. So if you were to like click on Canada, if you wait a second, it will put the image into this box and then give you Canada and the confidence level for that. So here's our specifications, and there's also a link to the Kaggle dataset which we used. And then here's our graphs, which you guys already saw on the slideshow. If you click, there's a cool animation, which my team added. And then also the confusion metrics. And you guys can also send the feedback to us. And now we can try the model. Okay, so this is an image of Japan, which we already found. And if we choose the file and then find that image, which you it's this one. Right. Yeah. It gives us Japan with 99%. So, and then we could try out a couple more. I believe the second, okay. Second was this photo. Let me just save it. Because, and that one was taken from Brazil, so it should give us Brazil with 99%. And then just to show you another cool thing, here's Finland, which is one of our classes for countries. And if you were to click anywhere on the Finland, click here. Okay. If I were to take a screenshot, let me save it. And if I put it here, the last one, yeah. it gives us, yeah, so our move not like as accurate. Yeah.
You can try an image of Finland with maybe more trees and like more features.
Yes, I will
You
try
have a
just
better time.
one more. Yep, good idea. Yeah, so let me do that. Just, yeah, this one seems reasonable. Don't know if I do. Oh, there it is. Yeah. Yeah, it gives us Finland with 99%. So you know how in the slideshow it was like 75% accuracy. So yeah, there you go. Thank you for listening and watching. Oh.